Today's video we are going to see an important topic of MSc Analytical Chemistry SAM 4. These techniques are very valuable and very important. So let's start our topic, hyphenated techniques. So first, what is the hyphenation technique? Now in this video we are going to see what is mean by hyphenation technique and what types of hyphenation techniques are available. So first, hyphenation techniques are where two or more analytical techniques or instruments are combined to form a new, more efficient device. The resulting methodology is termed as hyphenated techniques. It's mean when two or more instruments get combined and form a new instrument, and that instrument are very efficient and very less time consuming and very high potential, that we can say hyphenation techniques. Coupling of two or more analytical technique which the goal of the obtaining a faster and more efficient analytical tool. Uh, Almost all types of samples including organic metals, uh, inorganic metal ions are also analyzed successfully within a short time. There is some examples of hyphenation techniques. Today I am going to cover with only GCMS. Remaining we are continuing another video. So here these all are the instruments that are hyphenated. Here is the example of hyphenation techniques. First GCMS, second GCIR, and third is Hplc-Ms, and fourth is Icp-Ms. These all are the hyphenation technique. We all cover this one by one. So first we are going to see GCMS, gas chromatography with mass spectroscopy. The principal gas chromatography is able to separate the volatile and semi-volatile compounds, but it cannot be identify the compounds. Now we know gas chromatography we used to separate molecules on the basis of their stationary and mobile phase, and we can separate the volatile compounds and semi-volatile compound with the help of GC, but we cannot identify the compound, what compound are present in our structure of a compound or a molecule, but it cannot able to separate the molecule. For by this technique both identification and separation get combined to form a new technique, we can say hyphenation technique of GCMS. So now in this video we are going to see all the details about gas chromatography with the hyphenation of mass spectroscopy. Gas chromatography mass spectroscopy was the first technique. This is the first technique of hyphenation technique, and this technique are used to confirm the organic volatile compound and residue solvent with the great resolution. Uh, for the analysis of compound by GCMS, the compound should possess the properties such as volatility and polarity. When we use compound for GCMS, the compound should have a property volatility and polarity. Hmm. These two technique is the highly compatible with each other. The sample is vapor phase is required for whole the technique. The working of this technique, gas chromatography and mass spectroscopy techniques. Vaporized sample analyzed when carried through the GC column with the help of the heated carrier gas. The separation occurs in a column when we provide the in a gas chromatography with the help of carrier gas. A sample gets separated and it gets evaporated in the form of in the form of heat. They get evolve each other. Interaction of mobile phase and stationary phase led to separation of the compound. We all know with the help of mobile phase and stationary phase, the compound gets separate in the gas chromatography. The sample travel through the length of the column. The difference in the boiling point and other property led to the separation of the compounds. Here, separation occurs where in the there is different properties of the compounds. Boiling point, here is the difference between the boiling points and the properties of the other compounds. all these are important because of the something with different that will be make the error in our sample reading. The compound will be having difference in effluent time and retention time due to their different absorption or difference in the portion between the mobile and stationary phase. Uh, then the separated compound of mixture or sample enter into the GCMS with the help of interference. Guys, the interference are the one type of the compound, we can say a part of the GCMS that get combined and couple GC plus MS. This interference is used to join the GCMS. We can say interference when the separated compound gets passed through the MS for the analysis of the molecular structure. An interference like here we use this interference jet separator, membrane separator, diffusion separator, and for a diffusion separator. So now we are going to see what types what occurs inside the mass chromatography. The process of ionization not only ionize the molecule but also break the molecule into fragment and the detection this fragmented with the help of the electron multiplier detector. Here in a mass spectroscopy, when the uh, separated molecules pass through with the help of interference in the mass spectroscopy, they get ionized, and after ionization, the molecule will break into different fragment, and this fragment get with the help of um, electron multiplier tube they get detect electron multiplier tube is the detector of in a mass spectroscopy. So here the sample having the small mass 0.1 micron can be analyzed with accurate. The here is a compound should be 0.1 micro. What is the interference? The main and most important part of the GCMS interference because without interference this technique cannot possible. So what is the interference? Now in this topic we are going to see what is the interference. What is the interference of GCMS? So the principal difficulty in a coupling gas chromatography and mass spectroscopy is to introduce compound at atmosphere into high vacuum. The analyzed part of the mass spectroscopy is operate at the pressure of 10 raised to minus 5 to 10 raised to minus 8 torr. This lead to create a possible problems in combining of the GCMS to overcome this problem. Interface have been developed. When scientists get trying to join a couple with GCMS, there is a problem comes because the pressure of gas chromatography have very large and the vacuum of mass spectroscopy is difficult to adjust. For that purpose, scientists get discovered the mass interference is a help to join these two techniques. The three factors that are the considered in designing GCMS interference. What three factors we are going to see? The follow rate in a GC is 1 to 13 meter ml per minute and is in a mass spectroscopy is 0.1 to 2 ml per minute. The sample range and the samples follow rate is 1 to 13 ml in GC and 0.1 to 2 ml in ms per minute. Mass spectroscopy required high vacuum where GC operate at atmosphere pressure. So pressure uh, drop is necessary, which is done by the interference. Interference is for the interference that remove the unwanted pressure from the GC column and it reduce the vacuum of the mass. Amount of sample in effluent is a very small as compared to uh, carrier gas when the sample get analyzed in a gas chromatography and they get passed through the interference column. The remaining carrier gases are removed from the vacuum. So now we are going to see the first separate interference in a gcms. So first is jet separator we use. With the help of jet separator, when carrier gases is passed through the this is the this structure. So the jet separator, and we can say structure of jet separator. The carrier gas, these all are the carrier gases and they are from gc column. The carrier gases passes through the gc column. Small samples are inside the columns, and when they get passes through the this chamber, or we can say jet separator, the molecule which have the high molecular weight, and they get easily passed through the this membrane, and the carrier gets removed from the help of the vacuum chamber, or we can say vacuum. After, when samples get passed through the mass spectroscopy, jet separator column, inside the mass spectroscopy they get analyzed. The jet separator operates on the principle that the rate of diffusion of gas is inversely proportional to its molecular weight. It's enabled the carrier gases, usually helium, to elute out. Will it allow sample vapor to pass the mass spectroscopy? It is a glass tube having two fine jet separator by 0.5 to 1 millimeter gap, and surrounded by the evaluated tubes. Uh, in this separator, up to 50% carrier gas separate out from the samples. Now we are going to see second membrane separator. In membrane separator, from this side, gas from this connection is from GC, and sample get inside the membrane separator, and here is a polymembrane which are the made by the silicon, or we can with the made of the silicons, that is the use as a semi permeable membrane inside this column. This all carrier gases comes in the contact with the polymembrane and get separated, and remaining unwanted carrier gas remove out from this waste side, and remaining after filtration, or we can say after separation, with the help of polymembrane they get passes through the mass spectroscopy. The gases mixture passes from the polymembrane film such as silicon, which is more permissible to organic gases due to the solubility in the membrane material. Organic gases molecules are the dissolved in the membrane and released from the other side and become available for mass analyzer. Will carrier gas molecules remain undissolved and separate from the analyte.